Hello class. Today we're going to talk about our final lesson before the STAR test. So we're going to talk about angles within parallel lines, angles in triangles, and number systems. But first I want to look at this picture. This picture has some significance to this particular lesson. This is our last review. So I picked this picture as the graphic for this particular flip chart because you are right on the horizon. You are right on the edge of showing everybody what you know. And I know you're one of the smartest groups of students that I've taught in a long time, so I know you got this. So I want to go over just a few questions real quick, a few STAR questions, and then a few topics just to kind of finish us off. So the first question I'd like to look at is this one right here. Okay, this one says we've got triangle MNP is graphed on a coordinate grid with vertices at M, N, and P. Triangle MNP is dilated. Okay, so immediately I need you thinking, okay, it's either gotten bigger or gotten smaller by a scale factor of U. So we know that the scale factor is just a simple letter with the origin as the center of the dilation. Which ordered pair represents the coordinates of the vertex P prime? So we're focusing on just this point right here. Now we know a scale factor, as I've told you before, you're taking the coordinate and multiplying each value by the particular scale factor. So as we look at our answer choices, we know A, we have a plus. We know that that is a translation where we're just sliding things around. B is one that might trick you, okay, because it looks like we're multiplying or dividing, but what we're really doing is we're taking that 6 and multiplying by 1 over U, not just U. Okay, because when you multiply that together, you change that into a fraction and you end up with 6 over U. Letter C, you're doing the same thing. You're adding something to it, which means that it's a translation like A. So the only one that fits is D, because we're multiplying each of those values by the scale factor. So scale factor questions are really pretty simple. Okay, so keep that in mind. It's just multiplying by a particular number. A cylinder and its dimensions are shown in the diagram. Which equation can be used to find volume? The volume of the cylinder in cubic inches. Well, we know if you look on the formula chart, we have one formula for volume. Volume is equal to capital BH, or at least for volume of a cylinder or a prism. Now we have to look at the type of base that it has, and it has a circle. So we know that inside our capital B, which stands for area of the base, we're going to plug in our circle formula, pi r squared, and then multiply by the h. And now, it says which equation can be used to find V, the volume of the cylinder. So we're looking down here to find out which one actually fits. Now the part that they try to catch you on is the fact that of this circle, they give you the diameter, not the radius. So we know the radius is 2.5. So I immediately can eliminate B and D as my answer choices. Okay, so the answer has to be either A or C. But if you look at A, I'm squaring both the radius and the height. And we know that's not what we do in the formula. So the correct answer should be C. Okay, next one. Okay, we're talking about functions. And this one right here, it's saying which graph does not represent y as a function of x. Now, based on a graph, we know that in order to determine whether or not it's a function, is we use something called the vertical line test. So if I can drop a vertical line down anywhere along the graph, if I hit more than one point on the graph, then we know it's not a function. So if you look at C, you can drop vertical lines all day long and only hit the graph in one spot. Okay, D, the same thing. Even if the graph is broken, I'm still only hitting it in one spot. B, the same thing. Okay, I can drop vertical lines all day long and only hit the graph in one spot. The only one that's not a function is A, because I hit the graph in 2 spots. So which one is not a function? A. Now, one other one that's just like that, but they give you kind of some strange graphs here, says which graph does represent y as a function of x. So if we look at F, again, the vertical line test rules that one out. Well, on H here, if we do a vertical line like that, well, that vertical line hits every single point. So we know that one's not going to be a function. And J, again, not a function. So the only one that works is G. So both of those are ways of asking, is it a function or not? Okay, now we've got one other one here that it's a little bit tougher to determine whether or not it's a function. Okay, and that's when they use something called a mapping. So a lot of times in a mapping, it helps us to actually write out the points, because that's all this is showing is a set of points. So we know that one of the points is -1, 1. Another point is 0, 4. Another point is 2, 7. And the third point is 3, 7. Now, when we're looking at this particular thing, we know it is a function because we're looking at our x values. If all of my x values are unique, then I know, yes, it is a function. So that means I can come down here and for g, where it says the mapping does not represent a function, and j, the mapping does not represent a function, those can both be eliminated. So now we're looking at either f or h. And f says the mapping represents y as a function of x because each y value corresponds to exactly one x value. So we've got y value correspond to x, y to x, y to x, but this y value corresponds to a different x, but it's the same y value. Okay, so the y value corresponds to exactly one x value. This y value corresponds to two x values. So that one's not correct. Okay, we don't really care about the y value. We only care about the x. So if we look at h, the mapping represents a function because each x value corresponds to exactly one y value. And that would be the correct answer. Okay, so what about a scatter plot? Okay, a scatter plot is something we haven't talked about in a while, but it does talk about relationships. So if you'll look at the one that's on the screen, it says Julie made 25 international long-distance phone calls to London last month. The scatter plot below shows the length and cost of each phone call. Which conclusion can you make? Well, in this one, the dots are all over the place, so it appears that there's no relation whatsoever. So as we look at A, B, C, and D here, A, it says the length of the call, as the length of the call increases, the cost increases. Well, this would be an example of what we would call a positive relationship. As the length of the call increases, so does the cost. Okay? B, as the length of the call increases, the call remains the same. So this would be kind of like where it just kind of goes straight across. And again, neither one of those are correct. C says as the call increases, or the length of the call increases, the cost of the call decreases. So this is one that looks kind of like this. So that's what we call a negative correlation. And in all three of those, that's not what our first graph looks like. So in this particular one, it appears that there's no relationship. Because if you look at this one, you've got a call that's about 5 minutes, being way expensive up here, okay, over $5, and then a call that's 24 minutes only being less than 50 cents. So there's really no relationship between cost and length of call based on this scatter plot. Okay. Now, what I'd like to do is I want to go ahead, that's all the star review that I want to talk about. So now what I would like to do as far as the star questions, just kind of some random things. Now let's get back into the lesson that I wanted to at the beginning. Talk about angles with parallel lines, angles and triangles, and number systems. So let's finish this off talking about those things. The first thing I want to look at is some angles within parallel lines. Okay, there are several names that you need to know about, or several vocabulary words. So if you remember correctly, we did some problems just like this. We've got two lines that are parallel, and they're cut by this transversal, and there's some certain things, there are certain relationships that go along with that. So if this one is 124, then I know that these two angles right here, there's a relationship. Okay, and that relationship says that they are supplementary. Okay, and supplementary angles are just two angles that equal 180 degrees. Well, I also have on there a word right above that called complementary angles. And that's not involved with this picture, but complementary angles are two angles that equal 90 degrees. Those are two definitions that you just need to know. Now, because of supplementary, I know I can find angle 1 by subtracting from 180 and get 56 degrees. Now, there's some other relationships that go along with this. The first one I want to talk about is angle 1 and 2. Angle 1 and 2 are what we call vertical angles. And vertical angles are congruent. All of these words right here represent congruent angles. So angle 1 and angle 2 are vertical angles, so they are congruent. The 124 that's given and the angle 3 are also vertical angles, so they are congruent. Okay, the next one I want to talk about is corresponding angles. Corresponding angles are two angles that are in the same place along two parallel lines. So like here's this angle 1 and this angle 5. They're in the same place, so they are congruent to each other. Angle 3 and angle 7, they correspond. So this one is 124 degrees. The others are the same. So this 124 corresponds to angle 4, and this 56 corresponds to angle 6. So it's 56 degrees. So corresponding angles are angles that are in the same place. Now we have two others, alternate interior and alternate exterior. Alternate interior, interior meaning it's inside the parallel lines, okay, and they alternate on each side of the transversal. So angle 2 and angle 5 are alternate interior. Angle 3 and angle 4 are alternate interior. And then there's alternate exterior, which are the same thing. They lie outside the parallel lines and they alternate on either side of the transversal. So that's this angle 1 and angle 6, angle 7, and the given angle. Now, why would we need to know that? Well, because sometimes STAR will ask you questions like this. It says in each diagram, line K is parallel to line L, and line T intersects lines K and L. Based on the diagrams, which statement is true? So what they're asking about is, what's the relationship between those two 113s? And we know that those are alternate exterior angles. Same thing for these two, and same thing for these two. They're all alternate exterior angles. So with that in mind, how is this 79 related to angle X? Well, they're alternate exteriors, which means angle X should be 79 degrees. So based on that, my answer should be A. Okay, we also need to know some things about triangles. We know that the three angles of a triangle, this 40, this 110, and this missing angle here, if I were to add all three of those up, I would get 180 degrees. So to find this missing angle right here, I could add the 110 and the 40 to get 150 and subtract that from 180 to find this angle to be 30. Then I could subtract 180 again because this 30 and X, they're supplementary angles. So I can subtract the 30 from 180 and find out that this X degrees is 150 degrees. We also should know that an exterior angle, which is X degrees, is equal to the sum of the two remote interior, which are the two farthest away from it. Okay, so again, why would I need to know that kind of information? Because sometimes they give you questions like this. 4 triangles are shown. Based on these triangles, which statement is true? So again, this 130 is equal to this 40 and this 90. Okay, this 140 is equal to this 70 and this 70. Okay, so this 35 and 120 are equal to the 155. So what can I say then about angle W? How great is it? Well, if I take the 60 and the 45 together and add those up, I end up with 105, which tells me that W would have to be not 75 degrees. What am I thinking? Okay, that W right here, if we were to add these two together, we end up with 105, which is what that angle should be. Okay, and then this Z would be 75 degrees. So when we look down at our answer choices, I'm looking for the one that says that W is equal to 105, and then it gives you a reason for that. Okay, so that's one of the reasons why we need to understand the idea of angles. Now the last thing is number systems. Okay, we have to understand some things about these number systems. Okay, where we just understand how the numbers apply to each other. Okay, so we know that this first set of numbers, we know that they're what we call our counting numbers or our natural numbers. They're the ones that we do on our fingers, 1, 2, 3, and so on and so forth. And if we add one number to that set called 0, we end up with whole numbers. Okay, and if we look at all the numbers that are on the other side of the number line, we end up with our negative numbers, which are our integers. Then if we look at all the numbers that are in between numbers, like in between 1 and 2, we have numbers called rational numbers, or any number that can be written as a fraction. Okay, then we've got those numbers that cannot be written as a fraction, that are irrational numbers. Well, the most famous one is pi. Okay, but there are some others. And if you were to type in the square root of 2 into your calculator, you would get an answer that goes all the way across the screen. Okay, and it doesn't have a pattern of repetition. So that's how we recognize irrational numbers. But not all irrational numbers are going to have a radical. Okay, if they have a radical, that doesn't mean automatically it's irrational. Because if I do the square root of 4, the square root of 4, I get 2 as an answer. Okay, so not all radicals are going to be irrational. Okay, so make sure you type them into the calculator just to check. And we also need to remember that all numbers that go across the screen aren't always irrational because they may be repeating. If it's repeating, then it is a rational number. And then the last set is the real numbers, which is all of them. Okay, so here are some examples of some of those different types of numbers that we have. Okay, now there's one last thing I want to leave you with today in this video is some STAR prep. Okay, some test prep. What are some things that you need to do? Well, one, please make sure you get a good night's sleep. It's very important that you do get some sleep. Maybe put away your cell phone, put away your screen time a few minutes before you go to bed, because it will affect your sleep. Eat a good breakfast, or shoot, just eat. Okay, your body needs fuel to be able to do this test. Take your time, but not too much time, because it is a time test. You've got 4 hours to take it. It's a 3-hour test, but you do have 4 hours. If you don't know how to do all the problems, well, if you don't know how to do one, then skip it and come back to it. Okay, if you don't know how to do it in a minute's time, then skip it and come back. Okay, work the problem out on paper. Write it out before you type it into the calculator. Don't just go straight to that calculator. That's a way to make some careless mistakes. Check over your work when you finished, because that's important. Check over things. And that's the time where you go back and you look at all those problems you weren't sure of. And then check to make sure that you bubbled everything. Okay, so just remember, you've got this. You're one of the best groups of students that I've taught ever. Okay, so this is now time to prove it. Until next time.